In Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the general properties of ionic compounds. In our last lesson, we learned about the formation of ionic bonding. We learned that ions are electrically charged particles. We learned that metals typically lose electrons to form positive ions, and nonmetals gain them to form negative ions. In today's lesson, we will discuss the general properties of ionic compounds. We will discuss specific examples of ionic compounds in order to gain a better understanding of the concepts. We will start our lesson by discussing several experiments that will help us to investigate the melting point and solubility of some ionic compounds. For the first experiment, a few crystals of dry sodium chloride and copper chloride are placed into separate glass test tubes. The test tubes are heated to a high temperature on a Bunsen burner and then observed. Regardless of how long the test tubes are heated, the sodium chloride and copper chloride will not melt. In the second experiment, about 1 gram each of sodium chloride and copper chloride are placed into separate test tubes. Then, around 5 milliliters of water are added. The tubes are shaken well and then observed. Both the sodium chloride and the copper chloride dissolve completely. This same experiment is repeated 3 more times. However, instead of adding 5 milliliters of water to the test tubes, 5 milliliters of carbon tetrachloride are added, then 5 milliliters of hexane are added, and finally, the last time the experiment is performed, 5 milliliters of benzene are added. In each of these subsequent experiments, neither the sodium nor the copper chloride dissolves. Students, we have just discussed several experiments involving the ionic compounds sodium chloride and copper chloride. Please describe the general properties of ionic compounds that we have observed.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello, everyone. I wonder what general properties you described. In the first experiment, the ionic compounds did not melt when heated to a high temperature with a Bunsen burner. This is because the heat that Bunsen burners are capable of producing is far too low to melt either sodium chloride or copper chloride. The melting point of sodium chloride is 801 degrees Celsius, and the melting point of copper chloride is 498 degrees Celsius. Thus, we can conclude that ionic compounds have high melting points. In the next few experiments, we attempted to dissolve sodium chloride and copper chloride in different solvents. While both ionic compounds dissolved completely in water, neither of them dissolved in carbon tetrachloride, hexane, or benzene. Thus, we can conclude that ionic compounds are soluble in polar solvents like water, but not in organic solvents like carbon tetrachloride, hexane, and benzene. Were you able to correctly identify those general properties of ionic compounds? If so, well done! Let us continue our lesson with another experiment. This experiment will investigate the conductivity of some ionic compounds. To begin, some sodium chloride crystals are put into a beaker. Then, 2 electrodes that are made of either iron or graphite are placed into the same beaker. The electrodes are connected to a bulb and a 6-volt battery, as you can see in this image. At this point, it can be observed that solid sodium chloride does not conduct electricity. The bulb remains unlit. Distilled water is then added to the solid sodium chloride. The mixture is stirred until the salt dissolves. It can be observed that the sodium chloride solution does conduct electricity. The light bulb will turn on. This experiment is repeated 3 more times with solutions of copper chloride, benzene, and then charcoal. The bulb will light up when it is connected with the copper chloride solution, but not with the benzene or the charcoal solution. Both sodium chloride and copper chloride, which are ionic compounds, conduct an electric current when they are in solution because of their dissolved positive and negative ions. The benzene and the charcoal only contain covalent bonds, which do not produce cations and anions. Therefore, we can conclude that ionic compounds conduct electric currents in aqueous solution. Students, let us do one last activity. In a moment, you will see several statements appear on the screen, one at a time. Read each statement as it appears and determine whether it is true or false in regards to the general properties of ionic compounds.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. Were you able to determine which statements are true and which are false? Let us go through each one together. Statement A is false. Ionic compounds do not contain molecules. They are a collection of positive and negative ions. When they are in the solid state, each ion is surrounded by ions of the opposite charge. This produces an ordered array of ions called crystal, as you see here. Statement B is true. Ionic compounds are solids at room temperature because of the strong forces of attraction between their ions. Statement C is false. Ionic compounds have relatively high melting points. This is because of the strong electrostatic force that exists between ions. Extremely large amounts of energy must be applied in order to break these forces. Statement D is false as well. Ionic compounds are soluble in polar solvents, not organic solvents. Statement E is true. Ionic compounds are able to conduct electric currents in aqueous solution because of their mobile ions. In today's lesson, we learned about the general properties of ionic compounds. In our next lesson, we will learn about the formation of covalent bonds. This brings us to the end of our lesson today. Until next time, thank you, teacher. Thank you, students.